Before we start, drink some water. Okay. Replacing bash with Lua or Dash. The goal is effective shell scripting. The objectives are simplicity, portability, and reproducibility. These three overlap with each other. The value of one objective feeds into the others. Simpler means better portability, better reproducibility, and vice versa. We don't need to be too pedantic. These simply serve as a general guideline for us. Simplicity, how well our solution fits the problem. Portability, the ease of executing our script. Reproducibility, the consistency of its behavior across environments. Expounding on simplicity, the more we expose ourselves to irrelevant abstractions, the less simple our solution becomes. For example, using bash, which is written in 176,000 lines of code instead of Lua 5.1, which is 14,000 lines of code, exposes us to functionality unrelated to the problem, and by virtue, more bugs. Same idea with shelling out to external commands or libraries instead of maximizing the built-ins of the language or the runtime. Relying on tricky syntax or semantics, which diverts our attention to using the language effectively rather than solving the actual problem, and creating an abstract database factory for the day that we support 15 different backends. There's two ways to invoke bash, the normal way and through sh. If you didn't know, sh is a symlink wrapper to another shell. On most distributions, it points to bash. In others, it points to something like dash instead. Users can also change what shell it points to. Bash has this feature where it can detect when you invoke it as sh, and when that happens, it enables POSIX mode. It modifies its behavior to not conflict with the POSIX standard. However, this does not imply that it disables all non-POSIX features. In this discussion, we will take into account both of these invocations. Take a look at the script. We declare an array, arithmetic evaluation on the elements of the array. We index the array, two numbers, add them together, they should equal to the third element. Assume that sh points to bash. All of these are non-POSIX features, but bash will run this script successfully, even in POSIX mode. On Debian, where sh points to dash, this script will fail to run. Oh, there you go. Use cases to accommodate. Build systems, IO-heavy automation, CPU-heavy tasks, system management. We'll focus on build systems and IO-heavy automation. We'll touch on CPU-heavy tasks, but mostly parsing, and we'll forego system management altogether. PS, top, mount, DFDU, batch data processing, numerical computation, all of those things are nothing more than shelling out to an external command, since you'd want to use executables that are optimized for these tasks. So when I say build systems, I'm talking about bootstrapping, a problem that most projects need to tackle. Dev environment setup. So if your project officially supports Linux and Mac, you'd want to support an official way to set up the development environment. Other projects use Nix for this, configuration.nix. Package deployments, your release cycle. IO-heavy automation, I'm talking about log processing, data pipelines, streaming. Factors to consider are functionality, supported platforms, and appetite for vendoring. The importance of the objectives is directly correlated with the gravity of your factors. Functionality, if you just need a simple 20-line bash script, your supported platforms are Mac OS and Windows, then this video is not applicable to you and you should probably just use bash instead. Evaluating bash. As a language, it has tricky syntax and semantics. It's a large superset of POSIX shell, like I said, 176,000 lines of code. It's process-based parallelism and is centered on orchestrating CLI utilities, aka external commands. Most commonly, you'd be using the core utils. This is problematic because of the conflicting implementations of the core utils. On Linux, you have the GNU core utils. On macOS, you'd have the BSD counterparts. Each implementation introduces non-standard flags and behaviors that the other might not support. And both inevitably have their own bugs, simply because they are independent C implementations of the same standard. Because of Bash's tricky semantics, people are pushed towards the core utils, which have a relatively saner interface, but in my opinion, the core utils are hot garbage regardless. The ecosystem, it's pre-installed on most Unix systems. There's fragmented versions across environments. On macOS, you'd have Bash version 3.2. That's the latest, or that's the last MIT licensed version. On Debian and Ubuntu, you'd have 5 point something. And legacy systems, I'm talking about systems that refuse to upgrade from Debian 10. They'd have an older version of Bash. And then, like I said before, binsh is not guaranteed to symlink to Bash. On Ubuntu Debian, that's Dash. On Alpine, it's Ash. On FreeBSD, it's an actual executable. It's not SH is not a symlink wrapper. It's GPL licensed, which makes it difficult to vendor. If you're not familiar with licensing, GPL is a copyleft license. It's a viral license. And what GPL does is it forces software that interacts with it, be it as a library or as an executable, and forces those software to be open source. Now, that's not a problem if you want your software to be open source. But if you're a company that has proprietary code, that makes GPL software hard to interact with. Now, you might know that the Linux kernel is GPL licensed, but that's a different kind of GPL license. That it's the lesser GPL license, which permits software to interact with it, and yada yada. It's complicated to say the least. That's why companies tend to avoid the GPL license, and it matters that it's Bash is difficult to vendor because vendoring software helps the portability and the reproducibility of our project. We don't have to think about package managers or where people get this version of Bash or what version of Bash they have. And with vendoring, we avoid all of those headaches. Now, this is some Bash code, real Bash code that I wrote to bootstrap one of my projects. And I'm just showing this to remind you, or as a refresher, of what Bash code looks like. This is an unofficial changelog of Bash. It goes all the way back to version 2.0. You can see how, for as big of a language that Bash is, it's only getting bigger, creating more version fragmentation across the ecosystem. I mean, look at this. What the hell even is this printf nonsense right here? Anyway, how does Bash fulfill the objectives? It's definitely not simple. Portability. The greatest thing about Bash is that it's pre-installed everywhere, making it easy to run Bash scripts. Now, whether those scripts run as intended by the author, it's reproducibility, that's iffy. So Bash is not conducive to effective shell scripting. What would be our options, our solutions? Don't use Bash, pretend Bash is Dash, or use Bash. Solution 1, don't use Bash. Alternatives are Lua 5.1 and Dash. I understand that Lua isn't a shell language, but it is a worthy alternative. I'll show you a code snippet later of how I use Lua to emulate some shell features. As I mentioned, one of our use cases is build systems. I got inspired to use Lua because of Ginger Bill, the creator of the Odin programming language. These messages are from the official Odin Discord channel. What I found is that most build tools are fundamentally string manipulation tools. And at the end of the day, a scripting language like Lua or Python is a lot nicer to use as a build language. code gingerbill. So how does Lua compare to Bash? Let's talk first about adopting it. You download the source code, you compile from source, and then you commit both the source and the executable to VCS, usually Git. Now this is what I was referring to as vendoring. Lua is one of the easiest software applications to vendor out there. If you can get over the portability hump of it not being pre-installed anywhere, and instead vendoring it in your project, then all I need to do is show you that using it is better than Bash. Again, I got this idea from gingerbill. He says, with regards to cross-platform stuff, I usually embed Lua into the repo itself, so you can just call it there and then on all platforms. Evaluating Lua as a language, let's get it out of the way. It's one-based indexing. Yes. I actually prefer it this way. Some people might hate it. It's up to you. It's a small language, 14,000 lines of code. Compare that to Bash that has 176,000. That's, I believe, 12.5 times smaller. Yes, 12.5 times smaller than Bash. It's single-threaded concurrency with coroutines. And when it comes to parallelism, it's worse than Bash. Being single-threaded, though, however, does improve its determinism. If you really need parallelism, you can use Lua lanes or Lua JIT, or you just embed some Bash script inside your Lua script using os.execute, and then you have access to parallelism again. Okay, it includes a basic standard library. Oh, I skipped one. It's also finished software. So the last patch was released back in 2012. Yes. And it includes a basic standard library. Now, Lua has never been a batteries included language, and this is a negative on its part, but this does come with the trade-off of flexibility. We get to choose what functionality is introduced to our system and how. In networking, we have multiple options sorted by degree of control. We can use the standard library, shell out to curl, or use Lua socket. Now, I have a story. I created a bootstrapping script to set up my development environment for macOS. It was written in Go. I wanted to avoid external commands completely. I used the standard library to make up my HTTP requests, extract tar archives, checksums, all that jazz. It was a good learning experience, but was a painfully obvious example of over-engineering in hindsight. I ended up shelling out to curl and tar since they were pre-installed on the system, and I most likely would only be using Linux and macOS for my developer machines anyway. So there's that. There's a lot of ways for you to introduce functionality in your system. It doesn't have to be pure Lua or pure Go. You just have to be aware of what bullets you're biting. Anyway, ecosystem, it's not pre-installed anywhere. It supports practically all platforms under the sun. How? Well, one, the Lua source code is written in ONCC. That's the C89 standard. And all modern C compilers can compile Lua. All right, so as long as you have access to a C compiler, you can compile Lua from source. On top of that, Lua avoids a lot of platform-specific code, and this is related to the deficiency of Lua's standard library. You have to implement basic convenience APIs like file path handling, setting environment variables, multi-threading, because remember, a lot of the functionality in Lua's standard library is just interfacing with the C standard library. And when most people are only going to be using Linux, macOS, and Windows anyway, this specialization on portability actually hurts my case. That's why one of my project ideas is creating a standard library for Lua, something straightforward to vendor. Moving on, it's also MIT licensed. So this is the complete opposite of GPL licensing. MIT license is one of the most permissive licenses out there, besides unlicensed software. All you need to do is retain the attribution of the copyright to the authors and contributors of the software, and then vendoring the source and the documentation and, let's say, 3 executables for Linux, Windows, and macOS. That totals to 1.6 megabytes. That is a trivial storage cost to your Git history, Git work tree, or whatever. And open source libraries are mature. This is real Lua code that I wrote to bootstrap another project of mine. Taking a look at the first function, sh, this is basically os.execute, but it also emulates shell piping. If you take a look at the second function, checkout Odin, I use sh here. Looking at the second invocation, the last argument is a pipe. And what that does is now sh will return the string output of this command. Then I match that with my expected Odin version. Looking at the first invocation, the last argument is not a pipe. And now sh will return a boolean indicating whether this command was successful or not. Another shell feature that I emulate is sourcing. Source.zshrc, source.bashrc, and there's 3 main functionalities that we need to implement. First is mutating the process environment. First, we copy the process environment and manage it on our own, since Lua does not have a setEnv function in the standard library. Then we override os.getEnv from the standard library to use our copy of the environment instead. Next, we need to make the rest of the program aware of our updated environment and propagate that to any external commands that we execute. Using the sh function we created earlier, let's extend it to check which environment variables have changed since program startup, and then prepend that to the command that it's executing right here. Finally, sourcing. We source the file and sync with the new environment. We start a new shell, source the file, print all the environment variables, and then iterate over those variables, updating our current process environment. Sourcing has numerous side effects. This only cares about environment variables. Other side effects include aliases, variable and function declarations, shell options, and there's numerous ways to sync with these side effects. So I'll let you figure out how to do those things, but most cases, you'll only care about the environment variables. And I think I skipped over this comment I had. Yeah. If you import a library that exposes the setEnv API, so let's say you're using LuaJIT or you're using Lua POSIX, you can avoid all of this nonsense. Why Lua 5.1 specifically? The NeoVim documentation is a succinct explanation for this. It's minimal, it's frozen, and it's targeted by LuaJIT. Later versions beyond 5.1 are essentially different, incompatible dialects. Lua 5.1 is a complete language. The syntax is frozen. This is great for backwards compatibility. That's why you'll see a lot of the third-party libraries have Lua 5.1 as the minimum supported version. And then LuaJIT. LuaJIT is a just-in-time compiler that turns Lua bytecode into native machine code on the fly, making it one of the fastest runtimes on the planet, 10 times faster than Python. Now, I avoid performance benchmarks metrics in this discussion because it does not matter. It really does not matter. But when you're talking about one of the fastest runtimes on the planet. I have to mention it. Lua 5.1 ecosystem as of 2025. You got Penlight, which brings the Python standard library to Lua. It has 6.2 million downloads. Release date was this year, actually. Lua Socket, 6.6 million downloads. That's for your networking library. Last release date, 2022. Lua C JSON, this is your JQ replacement, 22 million downloads. So what I'm trying to show here is the ecosystem is mature in that libraries are stable and there's millions of downloads across all of them. By the way, these statistics are from Lua Rocks. So how does Lua fulfill the objectives? Simplicity, it is 100% simple. Portability, very portable as long as pre-installation is not a requirement. Arguably, it's too portable, which limits its standard library when 99% of you guys watching are just using Linux, macOS, Windows. Reproducibility, it has high reproducibility since it's finished software. It's small and easy to vendor with a couple caveats, however. The script can still be run by a Lua version beyond 5.1 or LuaJIT, which has numerous non-standard extensions, though guard checking against these environments can be done with a simple if statement. Debian Amquist shell. Amquist, I don't know, Dash. Hardcode Dash as the interpreter. Even if Dash isn't pre-installed in most distributions, if you're considering Dash, you're looking for a middle ground solutions besides Lua. Your supported platforms have Dash pre-installed, or you think it's fine to make users install Dash. Evaluating Dash. As a language, it's a tiny superset of POSIX shell, 13,000 lines of code. That is 13 times smaller than Bash. It's borderline finished software. When it comes to ecosystem, it's Unix only. It comes pre-installed on macOS, Debian, and Ubuntu. Even if it's not pre-installed on a lot of distributions, I'd expect these three to make up a large percentage of production environments and developer machines. So take that into consideration. It's written in C89, again, like Lua, and BSD3 clause license. So this is a similar license to MIT licensing, very permissive. So vendoring Dash, compiling from source, same thing. But it's better than Lua since it's pre-installed on some distributions. This is the official Git repo for Dash. And I say it's borderline finished software because when you look at the tag releases here and their frequency, they're on an annual basis and most of them are just patch updates. So it's slow moving software. How does Dash fulfill the objectives? Simplicity, it comes in second behind Lua. Dash is still a POSIX shell, so it's exposed to the tricky semantics of Bash, which incentivizes you to use external commands like core utils, like I said. Portability, it also comes second behind Bash, better than Lua because it's pre-installed on some systems. Reproducibility, I'd say Dash is the best out of the three. Despite it not being finished software like Lua, scripts written in Dash are not prone to misinterpretation by other shells or older versions of Dash. Solution number 2, use Bash but pretend it's Dash. One thing you can do is write your scripts using Dash before deploying them as SH or Bash. So let's talk about effective Dash scripting instead. Dash scripting guidelines. These sources are for Bash, but they're still applicable to Dash. You have Shell Harden and Google Cell Guide for safe Bash scripting. And then Pure Bash Bible. This is a, how you call this? It's a cookbook, a recipe cookbook for maximizing the shell built-ins so you can avoid using external commands. And then my own guidelines, which synthesizes these three. And then I have my own input on them, usually diverging, or not usually, oftentimes diverging from the recommended practices. Now, I'm not going to discuss these because it's better that you just read them on your own. since you'll be referring to these style guidelines constantly while you're scripting. Instead, I'll be talking about the conventions I've developed through experience, except for number 1, which is simply the most important best practice in shell scripting. Code parameter expansions. We have a string equation here, 1 plus 2, and we want to evaluate it with the expr command. And in the first invocation, we don't quote anything, and we get the answer number 3. That's correct. In the second invocation, we quote the addition variable, and now expr regurgitates the string equation back to us. In the third invocation, we don't quote anything, but we set this ifs variable to an empty string. Now expr regurgitates the string equation back to us. So what's happening here? Well, you need to be aware of 2 things. Number 1, parameter expansion. By default, parameter expansion will split up the value that it produces into multiple arguments based on some delimiter. The delimiter is defined by the ifs variable, also known as the internal field separator. Now you can have multiple characters in here, but by default it's set to space. So in our first invocation, we don't quote addition. Our string equation is separated by spaces, so now it will get turned into 3 separate arguments. First argument is 1, second argument is the plus sign, and third argument is number 2. And expr likes it that way. It wants numbers and the operators to be all separate arguments. Now when you quote parameter expansion, you disable this word splitting, and now expr sees this string as one single argument. Now it doesn't know how to parse this, so it just regurgitates the string back to us. In the third invocation, we set the ifs variable to nothing, so even if we don't quote this parameter expansion, word splitting does not happen. And now expr sees this as one whole argument again, and it regurgitates the string. My cat is calling me. She wants me to feed her. I'll be right back. Actually, you know what? I'll show you. Hey, come here. Come here. This is her. Chill out. Look at that baby. Look at that baby. Come here. Wash your hands. Okay. Crisis averted. Where were we? I think we were done with this slide, yeah? Yes. Always use long flags. You're probably familiar with this command, tar xzf, but I'm willing to bet you don't know what it actually means or what these flags stand for. So I'll give you 5 seconds to guess. 5, 4, 3, 2, 1. Okay. These flags mean extract gzip file. So X, you're extracting the tar archive. Z, you're unwrapping the .gz extension at the end. And then file, you're specifying the file. Dash capital C actually means directory. You're changing the working directory of tar before it starts unarchiving the tar archive. Now imagine that this was a different CLI utility that you're seeing for the first time. Now, I prefer this second way of invoking it instead of the first one. You can intuit what it's actually doing. With the first one, you'd have to find the documentation, read the documentation, and figure out what these aliases are actually doing. And for a lot of CLI utilities out there, they have insane short flags for things like you'd have a long flag that starts with the letter S, but the short flag would be a capital I or something. I don't know. Anyway, it's a horrible experience. Leave the short flags for interactive use on the command line. For scripts, please use long flags. And I'm not alone here. This is Matglad. He is the creator of the Rust Analyzer. That's the Rust LSP. Now he's working at Tiger Beetle, and he recently wrote a blog post on using long options in scripts. Yeah, and I highly recommend reading his blog. It's a high quality source of information, and I learned a lot about him, and you'll be exposed to their best practices in Tiger Beetle and how they develop this fault tolerant software. But I digress. Also, Ginger Bill again, he does not like long flags. So in the Odin compiler, you will only have long flags. You see this? There's only one dash. Yes, everything is long flag. There's no short flags. Oh, yeah, and he also used this as an example, XVZ. Okay, declare local variables even if local is non-POSIX. In POSIX shell, you can only do global variable declarations, but if you want to throw in a little bit of non-POSIX compliance in there, use the local keyword. It's going to save you from a bunch of headache, and it's going to save you a lot of time. And a lot of shells actually support the local keyword. Shells, a majority of the shells that SH symlinks to. So bash, Z shell, dash, corn shell, ash, yeah, all of those shells support the local keyword. Use test, avoid brackets. If you didn't know, brackets are not special shell syntax. That's a tongue twister. They're an alias to the command test. And the only difference is that they expect their last argument to be a bracket, a closing bracket. So if these are the same command, you can guess what the output of the second command would be. Spoiler alert, it's not the same. I'll give you 5 seconds. 5, 4, 3, 2, 1. It's a syntax error. We made a typo. We didn't separate the last bracket with a space. Remember, it has to be a separate argument. I'll fix the typo in 3, 2, 1. I hope you saw the difference. And now it outputs the correct string. These helper commands convert your scripts from using the bracket command to the test command. The first one is for neovim, and the second one is for sed. It modifies your file in place, so just be aware of that. Disable errfail. There's a lot of scenarios where errfail will not exit the script. If you don't know what errfail does, when you have a standalone statement, exit with a non-successful status code, it exits the script right there with a non-successful status code as well. You see here, even if I explicitly exit 0 at the end, the script fails with a status code of 1. In the second snippet, when we disable errfail, you don't need to do this. It's disabled by default. Even if test fails, it still exits with a status code of 0. Now, the sources I mentioned earlier, they recommend that you disable errfail. In theory, it's a good idea, right? When a command fails, you want the script to stop executing. But because of the how you say this, since there's so much scenarios in which that doesn't actually happen, it just creates an inconsistent mental model when you're scripting. Scenarios like conditionals, pipelines, well, not pipelines, piping, capturing the status code of the previous command, subshells, all of these scenarios, errfail will not exit the script. And from a language design standpoint, yeah, I get it, right? It makes sense. You're capturing the status code in conditionals and pipings. You want to use that, so yeah, errfail will not take into effect. Also with capturing the status code of the previous command with $? In subshells, they have their own environment. They cannot affect the parent shell. Yeah, that makes sense. But you see how thinking about these edge cases where errfail will not work. For what? And for what benefit, right? Just so you don't have to explicitly exit the script if a command fails. Like I'd rather you just do explicit error handling and just forget about errfail in the first place. And how would that look like? Well, right here, you do some short circuiting for a command. You exit explicitly, or you do some guard checking, like in Go. Use screaming snake case for environment variables only. Use snake case unless it's sensitive data or an environment variable that affects an external command. This is a GitHub Actions YAML snippet. This is some real production code that I wrote. The first block is where you declare all of your environment variables. Second block is where bash script goes to be executed for that job. You might be asking, James, if all of these are environment variables, why would you make title lowercase? If you're not familiar with GitHub Actions, if you have a variable that is coming from the GitHub preprocessor, best practice is to declare that as an environment variable for security reasons. Let's say someone puts in a SQL query in their pull request title. This protects you from SQL injection attacks, because I think GitHub will escape it. I don't know. All I know is it's best practice. Now, whether we make this screaming snake case, well, is it sensitive data? It's not. Does it affect an external command? We just use it in a case statement. So for all intents and purposes, this is just a normal variable that we declared as an environment variable for security reasons. What about random API key? Well, it's sensitive data, so we make a screaming snake case. AWS default region, this is for the AWS CLI. It's not like we have a choice here. So that's screaming snake case. Solution number 3, use bash in all of its glory, just like Google. I can't help here because I really try to avoid bashisms. Takeaway: after careful evaluation of bash, Lua, and dash with regard to how they contribute to simplicity, portability, and reproducibility for effective shell scripting, the takeaway is use Lua because I said so. The end.